All right, thanks for sticking with me. I know this is a lot. There's another two types of angles we're going to be talking about. One's angles that are inside the circle but not in the center. They have a relationship to the arcs on the edge as well. So we know the central angle is going to be equal to the arc. So I know that if I drew an angle from this point here to there, that would be 81 degrees. And that's not really helpful to get this angle. And I knew if I drew all the way to the edge of that circle, that would be half of 81. But again, that's not going to be helpful for this angle. So what we do is we do a little averaging. If I want to know what these two angles are, first of all, they're congruent. They're vertical angles. So that angle is going to be the same measure as that angle. Let's do a quick measure so we can verify that. If I measure this angle, I'm going to get about 53 degrees. And therefore, this angle should also be 53 degrees. I'm not going to remeasure that. But if you take the two intercepted arcs, the ones on the, since these are in between here, the ones to the left and right, if you add those together and divide by 2, that's 106 divided by 2. Oops. That's also 53 degrees. So we can just average these two, 23 plus 81, and that'll get you the angle in there. Now, we all know that two angles that form a straight line are supplementary, so this angle should be 180 minus 53, so that should be 127. So I won't remeasure that. That's 127. Therefore, the vertical angle below it is also 127 degrees. Well, let's verify a couple things. So first thing is I have all my arcs except for the one up here. So if I know that this is 135, this 25, and 81, I could add these three up and subtract from 360 to get the missing arc on the top. So 81, 25, and 135. That's 241. And the missing angle is the missing arc is 119. Well, let's verify that these two averaged together will get you 127. So if I do 119 plus 135, that's 254. If I cut that in half, there's my 127. So that relationship is pretty solid for all these circles. I simplified a little bit. I just say, they're going to be talking about two angles formed by intersecting chords. It's the sum of the intercepted arcs. I just say angle equals 1/2 parentheses arc plus arc, and just add the arcs together and divide by 2. So we can plug that into pretty much all of these formulas here. For 23, my angle is 65. That's facing these two arcs. So we say 65 equals 1/2. Arc is x and 85. So I'm going to get rid of that 1/2 by multiplying by 2. 2 times 65 is 130. And take away the 85, and 130 minus 85 is going to be 45. So that should be 45 degrees. Now let's verify that. If you go back and plug it into the formula forward, 85 plus 45 divided by 2 gets you back to 65 degrees. We could try number 24 and 25. Pause the video and try it on your own. My angle here is x. My arcs are 56 and 146, and those are facing the angle. So we're good to go on that. Just plug those in, average those two, and you'll get your answer. And x is 101 degrees. Number 25, x is an arc, and the angle that I want to use actually is not the 120. I want to use the angle that's supplementary to it. So I am going to take away, to get the angle, 120 from 180. So I'm going to use 60 degrees. Angle is 60, so I will say angle equals 1/2 arc plus arc. 60 equals 1/2 x plus 100. Again, kind of like the one above it, just double that angle, and then subtract the other arc. So that's going to be 2 times 60. Take away 100, and x is going to be 20. So 20 plus 100 is 120, divided by 2 is 60, and that's supplementary, so that's going to be the 120 there. 26 is, you're going to use the formula, but you do got to solve for a variable with not just an angle, but a variable. So what you're going to say is you're going to write the formula angle equals 1/2 arc plus arc, and the angle is the 5x plus 9. The arcs are 2x plus 3 and 135. So I will combine the 3 and the 135 to 138. Now you can distribute that, multiply the other side by 2 again. So that'll give me 10x plus 18. And take away the 2x, that's 8x. Take away the 18 from the 138, that's going to be 120. And 120 divided by 8 gets you what? 15. If you want, you can plug it back in just to make sure it works. So what I would do on that problem is plug in the 15 into 2x plus 3. And that's going to be 33 degrees. And same thing here, 5 times 15 plus 9. That's 84 degrees. And if you average the 33 and the 135, you're going to get 84. So the math checks. Okay, the last one on here is a ratio problem. So on this problem here, circle O is given at the right. A, B, and CD intersect at point E. If the measure of AD to the measure of AC to the measure of DB to the measure of CB is given by the ratio 3, 2, 2, 1, what is the measure of angle AED? Well, let's make sure we go in order. So AD is going to be 3, so I'm going to do 3x. AC is the next one, so that's going to be 2x. DB is the next one, that's also going to be 2x. And the 1 is the CB, so that's going to be 1x. And I want to know the measure of angle AED. So what is this angle measure? In order to get that angle measure, I would need to know the 3x angle and the 1x angle. So I got to find x, but I know all my arcs add to 360. So 3x plus 2x plus 2x plus 1x adds to 360. Eight x equals 360. I believe that's 45. So the value of x is 45. So that's going to put arc CB at 45 degrees. And 3 times 45 is going to be 135. And now I'm ready to get the angle that faces those two arcs. So I would do the measure of angle AED is 1/2 the two arcs, so it'd be 135 plus 45. Well, those add to 180, so it's 1/2 of 180, and that ends up being a right angle, so 90 degrees. All right, join me in the last video, and we'll do the one more angle type, and then you'll finally be done with all these different formulas and notes. Thanks for hanging.